Okay. It's on? Yeah, okay. Okay, ladies and gentlemen, welcome to the presentation today about our new innovative infrared TMOS sensor. This is a new breakthrough technology for presence and motion detection based on infrared emission. We will go through a little technology introduction about the working principle, the comparison with other technologies, our solution, the ST solution for TMOS, and application and use case examples. So what is TMOS? TMOS is a new technology. It's basically a CMOS sensor that is thermally sensitive, but optimized to measure thermal changes and thermal emission of objects in a room. Using this, let's say you can compare it like on the picture in the introduction with an infrared camera. You can have a static measurement of presence of thermal changes between the sensor itself and the environment in front of the sensor. Using this, you can detect movements, like with a PIR sensor, but also static presence, which is a big help. And it's really surprising how many customers we had on our booth asking for this feature. The trick here is also to make it with a very nice price target. So it's not the price target of an infrared camera, it's more in the range of the solution with a nice PIR sensor. This sensor is optimized to measure infrared radiation of 5 to 20 micrometer wavelengths and eliminating all the other rays around it. All is done then finally at a very low power consumption that allows to sense objects even with battery-powered sensors. Let's have a closer look at the technology inside. So this is a quite complex manufacturing of the package, but it helps then to give more information to the user. So what do we have? In this package, we have three elements. We have the sensing element. We have an ASIC that evaluates all this information. We have a shield that shields one of the sensing elements completely from infrared radiation, and another shield which filters out the environmental light. So giving this, we have the differential signal of the infrared radiation in the room. Here we have an ambient temperature sensor and a digital evaluation of all the information that is around. Then it's important to not to heat the sensing elements with the environmental with the package itself. So how do we do this? In order to have the best view on the sensors in the of the environment in front of you, of the objects or human in front of you, these sensor elements are made of arrays of CMOS sensor structures. But this CMOS structure is then operating in a vacuum. So there is no air conductive that transmits the energy to the field. And here there are little springs that eliminate the transfer of energy from the package into the TMOS structure. So normally we are used to have these springs in our sensors to measure acceleration, to measure movement. In this case, it's for thermal isolation, and there is nothing moving and we do not measure movement. But in the end, similar construct to sensors that we produce like 5 million a day with MEMS acceleration sensors. So here on top, we have then this infrared filter. And the ASIC is providing you a lot of information, what is happening. So there are like 25 registers that you can read with SPI or I2C. And from from this, you can set also in the registers the behavior of the chip. So it's no need of much, let's say, circuit design. So there's one chip, and you have around it, you have the circuit, you have everything else in the ASIC, and it can be programmed by the programmer of the solution. Finally, that's all features in a 14 square millimeter package with a little window. You don't need a Fresnel lens on top of the window. It is optimized to work in a room, like with a 4-meter distance, like for example, for ceiling mounting or for mounting in a wall, inside a display. There is no need to add a big Fresnel lens, and it's just needed to have a very small hole or infrared visible window. Then all of the parts are 100% calibrated inside the factory, so it's plug and play, easy to use. Where would you use it? As mentioned, so occupancy detection in smart home, smart building, smart IoT. It could be inside a display to switch on the display only if somebody's in front of it, but keep it on as long as somebody stands in front of it. That's what we call occupancy or presence detection. There is also a possibility of movement detection. And then beyond that, for context awareness, you can combine this sensor with other sensors, for example, time of flight. Then you can also read from it approximate number of people if you mount it in the right position, I would say. Then you can also use multiple sensors in one room. For example, if you want to detect at which seat of a room somebody is sitting, you have in a meeting area sensors on top of each seat. Then you can generate heat map and more sophisticated calculation of what is happening in a center, in a meeting center, for example. Then switch on and off the heating, the cooling, the light, and all the features that you need to build a sustainable technology. More about the working principle. So we have a field of view, which is 80 degrees. We have inside the chip the ambient temperature sensor. Then we compare the radiation from the field of view with the internal sensor. The sensor is calibrated on a black body with a 2000 LSB per degree or per Kelvin. And if a person, for example, moves inside the field of view, then you can see an internal value rising. And depending on what you want to sense or at which level you want to have an interrupt, for example, you can set a threshold for a specific interrupt. Now, the 80 degree of view is, so it's not like on-off 80%, so it's a Gaussian curve because we have this little window. That means you can even detect something that is a bit outside the 80 degree, because 80 degree here means 50% of the value of the amount of radiation that is set to detect it. Outside, for example, 130 degree, you have just 10% of the radiation that can be detected, but it's still working. On the other side, if you want to have a more focused sensor, then it's still a possibility to add a Fresnel lens. So we cooperate with some companies that provide the Fresnel lens, and these are examples what you could do. So it's, as I said, it's not necessary, but in case you have a specific need for a smaller field of view, like 22 degree here, you add one type of lens. If you want to have specific multiple field of view, you add a different lens. Doing this, for example, with a narrow field of view, you can detect also humans in a distance of 10 to 15 meters. Now let's have a more close look at what we can derive from the signal. If you look at the signal that you would usually get from a PIR sensor, you see there is no difference between if somebody arrives in the field of view or somebody leaves in the field of view, the black curve here. While with infrared radiation measurement, you understand if somebody is arriving, because it's here a positive motion signal, and if it's leaving, so it's a negative motion signal. We have also the possibility to generate a flag, which is then related to this to the limit here. And if more people come, you get more flags. You have a presence which is related to the infrared emission. And again, the more people there, the higher is this signal. And you can also set here a threshold. For example, if you put it here, then it would generate a flag when the presence of the person is detected. Yes. That means we have here the possibility of three different information by two different flags, and without using the flag, but the amount, we can also detect how close or how many people are in the room. All of this in a very small package, so smaller than what we typically have for the PIR. It's easier to solder because it's an SMD component. We don't need the lens. Then we have temperature sensor, which is quite precise. So we have the 0.3 degree in a typical ambient environment. We have the simple hardware design because there's no need for all the circuitry typically around a PIR, or if you use high-end PIR, it's much more integrated and more cost-effective. Then we have the robustness against EMI and the direct light, the visible light for the humans. So we have more info. Let's say have a closer look at the logic inside the ASIC. So using the information from the temperature sensor and the ambient temperature and the differential signal from the two infrared radiation signal, we can conclude what is ongoing around. We can set the flags. All this is done by the programmer, so it's mainly programming effort that has been done, but not the integration in the physical design. There are different low pass and filters that you can set. So you can set also the slopes which you want to detect. And finally, based on the motion or presence, you get flags that you can read and control your smart home or smart building. Finally, there is one more signal which is available. So beside the presence and the motion flags, we have an ambient shock flag, which is rising if you have a very sharp decline of the ambient temperature, which could be, for example, if you open a window and you want to switch off heating during the time where the window is open. Good. Let's see what other technologies can do. As mentioned, typically PIR is a technology that is very often used, but has the limitation that it cannot detect real presence. It would detect if somebody is moving, but doesn't know if arriving or leaving. Then for the field to have a visibility of a room, you definitely need a lens. Otherwise, it would not detect the movement. Then we have the thermopile. Thermopile is a bit similar from the technology behind because it works on the absolute temperature. But typically, it's used for very short distance measurement and more for temperature sensing, not as a presence detector. In the end, you could use also radar solutions, but a radar on the other side has, let's say, is not so nice in a room because you do not want to be polluted with EMI emissions of a radar. So this is some technology that theoretically could be used, but it's more like in very long distances or outside. So typically we compare to PIR, or we could also say time of flight, but I would say time of flight is more an extension because it gives a ranging signal, which is a very precise ranging, but not necessarily presence of an different temperature object in a room. So let's think about how to use it. If you want to measure if somebody is passing by in a room in 3-meter distance, so he has, due to the field of view, he's walking 4 meters inside this field of view. So even if it's the guy is running with 3 meters, so it's 10 kilometers per hour, it's running, you would easily detect him. If you want to detect something closer to the sensor, like a wave with the hand, then could be useful to have higher speed, so like 4 Hertz. You see that like with slow sensing, you need 7 to 11 microamp, which is definitely suitable for a battery-powered device that can then send the information that is derived from the sensor by some RF to control somewhere else. If you want to go with a very high speed, you can increase the speed up to 30 Hertz. So it's then very fast reaction to any movement nearby. So we compare here on a little demo board. You see, so this is a 1-inch board, and this is the sensor here. This would be a PIR or a TMOS with a Fresnel lens. So it's really very small for integration and could be put behind some black window. So we have a very nice power consumption and easy integration. Comparing with other technologies, we have here, for example, the TMOS PIR and thermopile, because the others are a little bit different from the target. You see most of the green stuff on the left side, and also the package size is very nice, very small. We have good accuracy, we have super power consumption, we have a range of 5 meters, so that means sensing for 1 room without any additional lens. Very easy integration. And the really big difference, which is here, is the stationary detection if somebody is sitting in front of the room, in front of the sensor. Let's go again to the applications. So where could we use it? So everywhere you need to have a sustainable usage of technology to switch on and off displays, to switch on and off lights. You could even do control of something. And let's say this is a more intelligent usage of the sensor. So despite it has only 1 pixel, we have application node how you could detect even if somebody is moving from left to right or right to left over the sensor, to have some control which is more than the control of just presence detection. But it's something we can explain in an application node. Finally, security alarm systems, power saving, very nice use of the technology. And that all comes with a low power consumption of just 10 microamps. We detect the stationary of objects. So objects means typically human body detection, but there is also a possibility to detect objects that are below ambient temperature. So you can set it in a way that it detects objects like human body, which are higher than the room, but it works also on the other side. You can switch it in a way, in an operation mode, that it detects objects that are colder than the room itself. All this in the small package and set by digital algorithms by the programmer of the device. So this solution is called STHS34PF80. It's our single pixel motion and presence detector. The component is on our website. You just look for this part number. There's a data brief. It will be available soon, so next quarter. And you just connect it to the typical voltages available in your system around 3 volt, and its operating needs to be programmed. If you want to try, we have evaluation kit. So this kit consists of a microcontroller board with an STM32. It's connected then our sensor. So the sensor is on an additional target board, which you can more easily move in a specific direction. We have a software GUI that allows setting of all the parameter of all the registers, read out all the registers. Then you can very nicely see also by movement of measured temperature in front, the setting of the presence and the motion flag, which you can then very easily use to control other devices. I would like to invite you to have a look at this technology in this hall 1, booth 320. And now would be a good time if you have any questions already, otherwise. So we have time for answering some questions. Everything is clear? Then I would be very happy to see you at our booth. I think some of the people here in the room I have seen already, and it was very nice to see this interest, because it's good to see that this feature of presence, real presence detection is really a breakthrough at very low effort for integration and price. Thanks, and see you again.